Hello everyone. In the previous lecture, why do the eyes move? We have learnt about the 6 types of eye movement systems. Now, let's discuss these eye movement systems in detail. So, I'll be discussing about the visual fixation system, the optokinetic system, the psychotic system, the pursuit system, and the vergence system. You must have learned in your earlier lectures regarding the vestibular system. So I am not going to touch that part. Now, firstly, let's go through this visual fixation system. The fixation system holds the image of the stationary objects on the fovea when the head is immobile. If you recollect from my earlier lecture, the vestibular system holds the image during a brief head movement, and the optokinetic system holds the image on the fovea when there are sustained head movements. But visual fixation system holds the image on the fovea when the head is immobile. So, really, does the eyes stay still? The answer is no. Steady fixation is an illusion. Even the fixation system is not an exception for not having a fatigue. Even the fixation also have fatigue. So to overcome that, the fixation system have developed 3 types of miniature movements which are not being able to be detected by the human eye. The 3 types of the miniature movements are the microsaccades, the micro drifts, and the micro tremors. So coming on to the microsaccades, these are the miniature saccades. They have an amplitude of less than 26 arc minutes or the minutes of arc. So what exactly is the terminology of the minute of arc or arc minute? So arc minute is the unit of angular measurement. So 1 arc minute is equal to 1/60th of 1 degree. As we all know, 1 degree is equal to 1/360th of a turn. Therefore, 1 arc minute is equivalent to 1/21,600 of a turn. So, don't worry about these calculations because the angular measurements are measured in arc minutes and arc seconds. So, these microsaccades will be having an amplitude of less than 26 arc minutes. The average amplitude being 6 arc minutes. So the mean frequency of the microsaccades is 120 Hz. Unfortunately, no known function has been ascribed to these microsaccades, and they are considered to be the unneeded movements. Coming now to the micro drift. These are the smooth eye movements that occur with a velocity of less than 20 arc minutes per second. They are necessary to prevent fading of the image of a stable object on the fovea. The next is the micro tremor. These are the continuous high frequency activity that underlies both micro drift and micro saccades. These micro tremors occur at a frequency of 50 to 100 Hz. The average amplitude being less than 1 arc minute, usually between 5 to 30 arc seconds. And they are much smaller than the amplitude of the microsaccades. Now, after knowing about these three miniature moments, for the eye to fixate on an object, this visual fixation system needs the participation of so many cerebral structures and the brainstem structures. Visual fixation is an active process, not merely in absence of visible eye movements. We need to note down this point. Visual fixation is an active process. It's an ongoing active process. It's not merely the absence of visible eye movements. Several cerebral cortical structures participate in visual fixation. They include the parietal eye fields, which includes the lateral intraparietal areas, that is the lip. You need to remember these things because you will be encountering these areas in multiple systems, in other systems too, like the pursuit system and also in the saccadic system. So the parietal eye fields include the lateral intraparietal areas and area 7A. The other areas from the temporal lobe or the middle temporal and the medial superior temporal areas, described as V5 and V5A respectively. The supplementary eye fields and the dorsolateral prefrontal cortex are also involved during visual fixation system. So there are four areas of the cortex, that is the parietal eye fields, the temporal eye fields like the middle temporal and the medial superior temporal, the supplementary eye fields and the dorsolateral prefrontal cortex. If you notice, there is participation of the frontal lobe, the temporal lobe and the parietal lobe. If you notice, the occipital lobe is not involved here. Coming on to the brain system, brainstem participation. So these structures that are important and participate in the visual fixation from the brainstem are the basal ganglia and the rostral pole of the superior colliculus. Actually, basal ganglia does not come under brainstem, but I have involved it here for the sake of memory. So the basal ganglia, particularly in basal ganglia, the substantia nigra pars reticulata and the rostral pole of the superior colliculus, the level of the midbrain. These are also involved in fixation. In this picture, You can see the areas what we have dealt till now. These are the parietal eye field areas, which include lateral, intraparietal area, the lip, and the area 7A. And this is the area V5, that is the middle temporal area. And this is the V5A, that is the medial superior temporal area. The supplementary eye fields and the dorsolateral prefrontal cortex. Now, why should we learn this regarding this visual fixation system? So the involuntary disruption of normal fixation leads to oscillopsia. As we all know, oscillopsia is the illusion of movement of the stationary environment. So oscillopsia can be caused by ocular oscillations, which include nystagmus, the saccadic intrusions, and the saccadic oscillations. So we'll see the differences between these three in the next slide. So oscillopsia occurs in peripheral vestibular dysfunction, like the bilateral vestibulopathy, the central vestibular dysfunctions, in seizures, and also in occipital lobe infarction. We have seen the visual fixation system, the neural substance. Occipital lobe is not involved. But because of the occipital lobe infarction, the signals from the striate and the non-striate or the peristriate cortex does not get relayed in the parietal eye fields and in the temporal eye fields. So that's why even occipital lobe infarction can cause oscillopsia. Now let's see the difference between the three types of the ocular oscillations. The first one being the nystagmus. As we all know, nystagmus is initiated by the slow eye movement, and the continuation can be again a slow eye movement where we call it as pendular nystagmus, or the continuation can be a saccadic movement where we call it as jerk nystagmus. The second one is the saccadic intrusion. The saccadic intrusions are the intermittent oscillations initiated by fast eye movements, whereas the saccadic oscillations are the sustained oscillations. That means it will be sustained and they are also initiated by the fast eye movements. So from this lecture, it's important to know that the steady fixation is actually an illusion. Normal fixation consists of three distinct types of miniature movements: the microsaccards, the microdrips, and the microtremors. So involuntary disruption of the fixation can cause oscillopsia. With this, we'll conclude this section. Thank you.